My goal is that by the end of this video, you feel a lot more comfortable and a lot more confident working with the commutative and associative laws for vector additions. And if we haven't met before, my name is Mariano. This channel is all about sharing the often overlooked details in physics so that we, as a whole, can get a better understanding of the world we live in. And I also love anime. So drop down what you're currently watching. I'm on One Piece and I'm loving it. But let's get started. So we're going to start off with the commutative law. And as you may know, that simply states that a vector A plus a vector B is equal to B added to A. So all that's happened is we changed the order in which we're adding things. And now let me go ahead and prove that to you. And the important thing to take note is that this is a geometric understanding. Like, sure, you can add the components of various vectors together all day long, but the true insight comes from understanding the geometry of it, looking at it when it's drawn out. And this is what it looks like. Vector A plus B gives you this resulting vector, A plus B. So now let's really make it click and let's do the reverse. Let's do vector B plus vector A and let's see what that gets us. And that's going to give us this resulting line right here. And as you can see, even in this crude drawing, these two vectors are exactly the same. So that's the proof. It pretty much states that no matter the order in which you decide to add two vectors, your result is going to be the same. So let's move on to the associative law, which pretty much is a bigger brother to the commutative law, and it states that three vectors. You have A plus B plus C, and it's going to be the equivalent of saying A plus B plus C. So as you can see, all we're doing is adding two vectors first and then adding the third vector. So let's go ahead and prove that geometrically again. So let's say we have these three vectors. This is A, this is B, this is C. And now let's add A plus B. There you go. This is A plus B. Now we do A plus B plus C, giving us this final vector here. Okay, so that's what that's going to look like on the left-hand side. Now, of course, let's go ahead and do the reverse. Let's draw out our vectors again, trying our best to make them match. C, B, A. All right, this is going to be B. Actually, let me redo that. This is B plus C. And guys, if this is your first time here, let me know if anything clicks in the comment down below, if you learned anything valuable. Because at the end of the day, the thing that you share might be exactly what another student needs to learn. Okay, so this is a resulting vector, A plus B plus C. And hopefully you can get a sense that even though my drawings weren't the best, these two vectors are exactly the same. So that's the associative law for you. Again, it's pretty much just a bigger brother of the commutative law. So now let's move on and I'll tell you what our main takeaway from this is. So here's what I want you to leave this video knowing. And it is that the order in which you add vectors doesn't matter. And that is a pro level insight, because once you realize that vectors can be anything, can be forces, velocities, displacements, this pretty much just tells you that the order in which you add them is going to get you to the same result, no matter what. So if you learned something from this video, I just encourage you to leave a comment. What did you learn? Or just tell me your favorite anime character. I think right now, mine is Shanks.